Hello everyone. Today we are going to discuss about the simplification of Boolean expressions using K-maps. So in the previous class we have learned about how to represent the Boolean expressions in the K-map based on the type of the given expression. So now in today's session we will understand how to simplify the Boolean expressions. Now, based on the required resultant simplified expression, we can either group logic 0 values in the K-map cells or logic 1 values in the K-map cells. So this grouping can be done by the following priorities. So the first priority we have is octet, that is 8 adjacent cells. So octet will be given with the highest priority. Next we go for looking at 4 adjacent cells, that is square. It can be either logic 0 cells or it can be logic 1 cells, which will be based on the required resultant simplified expression. The next priority is adjacent 2 cells where we are forming a pair, and the last priority will be a single 1 cell. So this single cell can be either 0 or 1 based on the required resultant simplified expression. Now quickly we shall go to the example and simplify the Boolean expression. In this example, we have an expression f of ABC equal to summation m 3, 5, 6, 7. So this is a minterm canonical form. This minterm canonical form is expressed here in terms of variables, that is minterms a bar bc plus a b bar c plus a b c bar plus a b c. Now let us plot the expression in the K-map. So let me plot the expression. Let us represent, as the function is a 3 variable function, we need to have 8 cells in the K-map. So 2 power 3 gives you 8. So the input variables are A, B, C. So for the rows, I'll represent variable A, and for columns, I'll represent variables B, C. So A can have value 0 and 1. B, C can have values 0, 0, 0, 1. We need to interchange the column here. Therefore, 1, 1 and 1, 0. And we shall fill the values in the K-map. So as the given expression is a minterm canonical form, for the respective decimal numbers given in the expression, you need to place logic 1. So for cell numbers 3, 5, 6, 7, you need to place logic 1. So we have 0, 1, 2, 3, third cell number is this. So we'll write 1 here. Then 4 is 0, we have 5, 5 is 1, 6 is 1, 7 is 1. In the remaining cells, you need to place logic zeros, as the given expression is minterm canonical form. Now please look into the K-map and identify or find out whether you have 8 adjacent logic 1 cell. Now let us obtain the simplified SOP expression. So we will obtain simplified SOP expression. In order to obtain simplified SOP expression, you need to group logic 1s. Okay, group logic 1s. Suppose you need to obtain POS expression, POS simplified expression, you need to group logic zeros. Now in this example, we shall go for obtaining a simplified SOP expression. Therefore, we will concentrate on logic 1 entries in the K-map. From the K-map, we can see that we don't have 8 adjacent logic 1 cell. Therefore, we cannot group octet. We cannot form an octet. And we also know that we do not have a adjacent 4 cells in order to form a quad. Therefore, quad is also not possible. The next priority comes to the pair. So we find 2 adjacent logic 1 cells here. So we can form pairs here by considering these 2 logic 1. One more pair here considering these 2 logic 1s. One more pair here considering these 2 logic 1s. Okay. So all the logic 1s in the given K-map is covered by forming some grouping. That is, we have formed pairs here. So let us write the simplified expression. So simplified expression, I am going to represent an SOP expression because we have group for logic 1s. So let me write the terms, product terms for each of the pairs here. So let me consider the first one. In order to write a product term for this pair, you need to consider the rows of this particular pair and also the columns. Let us consider the rows of these particular pair. When we consider the rows, the row value here is 0 and 1, which is changing. So when you have such value changing variable, you cannot consider. Okay, so we will eliminate a variable in this product term. Let us go for the column. The column value is with respect to BC variable, where we have B as 1, C as 1. So when you write a product term, 1 will be considered as uncomplementary variable. So we can write the product term here as BC. Similarly, let's write the product term for this pair. Let us consider the rows and columns of this particular pair. This pair is occupied the respective row as shown here, and also these two columns. Okay. So now what is the value for this row? We have 1 with respect to a variable. So we can write the product term now as A, because a variable is having value 1. Let us go and check for the column values. So when this pair is occupied by these two columns, we need to look for both the values here. So we have 0, 1 with respect to BC, 1, 1 with respect to BC. You need to consider a variable with a constant value. So we have a constant value as 1 for variable C. As the constant value is 1, we need to write the variable as C. So the product term for this particular pair is AC. The next we will go for writing a product term for the next pair as shown here. This pair is occupied by this row and also these two columns. Let us now write the product term. Considering the row, we have a constant value as 1 with respect to A. So the product term will have A here, and let's go for the columns. When you consider the values under the column with respect to B, C variables, which variable is having a constant value? B variable is having a constant value as 1, right? So C value is changing. So you can neglect C variable. So the product term for this particular pair is A, B. Now let us write the SOP expression as we have written the product terms for all the pairs in it. So F will be the simplified expression. F will be AB plus BC plus AC. So this is the simplified SOP expression for the given Minterm canonical form using K-map. Suppose if you want to obtain the product of some expression at the end, the simplified POS expression for the same plot, you need to go for logic zeros. In the next example, we have a Maxterm canonical form given in the example. So we shall plot the Maxterm canonical form into the K-map and obtain the simplified SOP expression using K-maps. So let me start with the plotting the K-map for the given expression. As this is a Maxterm canonical form, you need to place logic zeros into the K-map. So the variables here are A, B, C. Let me write the values for rows with respect to A variable. So it is 0, 1, BC 0, 0, 0, 1, 1, 1 and 1, 0. For the decimal numbers 0, 3, 5, 7, that is the cell numbers 0, 3, 5, 7, we have to place logic zeros in the K-map. So this is 0, cell number 0 is 0, next cell number 3 is 0, next cell number 5 is 0 and cell number 7 is 0. For the remaining cells, you need to place logic ones. Okay. Now, as we are trying to obtain the simplified SOP expression, okay, simplified SOP expression, we need to group for logic ones. Group logic ones. Suppose if we require the simplified POS expression, then we have to group for logic zeros. Okay, now we are concentrating on obtaining a simplified SOP expression. Now let's group for logic 1. So please look into the K-map and find out whether you have all 8 logic 1s adjacent to each other. No, we do not have 8 logic 1 cells adjacent to each other, so octet is not possible. Similarly, we don't find 4 adjacent logic 1 cells, so we cannot group for quad. So next we can opt for pair. Okay, so you can see that in the K-map we have 2 adjacent logic 1 cells, so we can form a pair here. Let me form a pair. So this forms a pair, and still there are 2 more logic 1s left out, which in order to cover these 2 logic 1 cells, we cannot form octet, we cannot form quad, we can go for single. So we can go for single, and all the logic 1s in the K maps have been covered. Now let us write the product terms. Why we are going to write product terms for these grouping? Because we have grouped for logic ones. Please remember, when you are grouping for logic ones, you need to write product terms. When you are grouping for logic zeros, you have to write sum terms. Okay. So let me write the product term for the first grouping, that is pair. So look into the rows of this particular pair. If you look into the rows of this pair, the variable A is having a value 0 and 1, which is not constant, so you cannot consider variable A. Now let us go for the columns, that is BC, having values constant value for B variable and C variable as 1 and 0. So the product term for this particular pair is BC bar. Okay. Next we shall write the product term for the single cell logic 1. Look into the rows and columns of this particular cell. So row is having a constant value 0 with respect to variable A. So we can write A bar here. Next we will go for the columns of this particular cell. We have constant value for B as 0, constant value for C as 1. So the product term for this grouping is A bar, B bar, C. Similarly, product term for the next grouping will be A, B bar, C bar. Just look into the rows and column of this grouping and we can write the product terms. Let us now write the simplified expression F equal to, as we have grouped for logic ones, we have written the product terms and we are obtaining the simplified SOP expression. Just the summation of all these product terms will result in the simplified SOP expression. So we can write the expression as A bar B bar C plus A B bar C bar plus B C bar. So this is the simplified SOP expression. Next example is simplification of given Boolean expression. Again, it is a Minterm canonical form. So let me plot the K-map here. The variables are A, B, C. So 0, 0, 0, 1, 1, 1, 1, 0. Similarly for rows, we have 0, 1. So as this is clearly given as a Minterm canonical form, then we shall write the variables here. 0 is represented as A bar, 1 is represented as A, and will represent B bar, C bar. This is B bar C, this is BC, and this is BC bar. Okay, so we shall plot the K-map. The first minterm is A bar, B bar, C. So find out where we have A bar, B bar, C. So in row 1 and column 1, we have A bar, B bar, C. So as this is a minterm, we have to place logic 1. Okay, so next we shall see A bar, B, C. The next minterm is A bar, B, C. A bar is present in row 1 and we have BC in third column. A bar, BC, therefore you need to place logic 1 here. Next minterm is A, B bar, C bar. A you can find in the second row and B bar, C bar again in the first column. Therefore, we have to place logic 1 in this particular set. Next minterm is A, B, C bar. A is present in second row and B, C bar is present in the fourth column. So the cell number here we place logic 1, that is A, B, C bar. In the remaining cells you have to place logic zeros. Let us now obtain the simplified SOP expression again. So you cannot form an octet here, you cannot form a quad here, so you can go for one pair and two singles. Let's write the expression, simplified SOP expression, as you are grouping for logic ones. So the simplified expression is the product term for particular pair, whatever we have done here, will be B bar C bar, plus for the single we have A bar B C, plus for one more single we have here the product term will be A B C bar. So this is the simplified expression. The next example is a function with 4 variables. So 2 power 4, that is total number of input variables, will give you 16 cells in the K-map. Therefore, we have 4 variable K-map represented here. Let us now write the variables in the K-map. So that is W, X, Y, Z, 0, 0, 0, 1, 1, 1, 1, 0. Similarly, here we have 0, 0, 0, 1, 1, 1, and 1, 0. As the given expression is a Minterm canonical form, for the respective decimal numbers given in the function, you need to place logic 1s, and in the remaining cells, you have to place logic 0s. So let us now fill the K-map for the respective decimal numbers. So this is 1, 1, 1, 1, 1, 1 here. Next 1, 1, 1, 1. In the remaining cells, you need to place logic 0s. Let me cross verify. So here we have cell number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have to place logic ones for this cell numbers 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, 14. So from the K map, what we have plotted, we can easily identify that we have 8 adjacent logic 1 cells which forms an octet. So you have to always start with a higher priority grouping. Therefore, we can form one octet here by considering 8 adjacent logic 1 cells. So there are still 3 more logic 1s left out in the K map. In order to cover these 3 logic 1s, you can start with the highest priority. So the highest priority octet is not possible. Even if you fold the K map, you cannot form the highest priority octet. Then we can look into the quad, whether quad is possible or not. So by folding the K map, you can see that these two logic 1 cells will be adjacent to these two logic 1 cells, which we can form as a quad. So we will form a quad here. Next, again by folding the K map, this one more logic 1 is left out. You need to cover this logic 1. Start with the highest priority. Even if you fold the K map, you cannot form an octet. Now we can easily see that by folding the K map, these two logic 1 cells are adjacent with these two logic 1 cells. That means we can form an quad by considering these 4 adjacent logic 1 cells. Now from this grouping in the K map, we have covered all the logic 1 cells, and let's write the product term in order to obtain the simplified expression. So let me consider the first grouping octet and write the product term as we have grouped for logic 1s. If you look into the rows of this particular octet, all the variable values are varying every time. So you cannot consider Wx variable in the product term. Let's go for the column values. If you look into these two columns, we have a constant value of 0 for variable y. Variable z is having two different values, 0 and 1, so you cannot consider variable z. Look into variable y, which is having a constant value 0. Therefore, we can write the product term here as y bar. Let us go for the second one. Second grouping is this. If you look into the rows of this grouping, these two rows have been occupied by this square, and these two columns have been occupied by this square. Let us first consider the rows of the quad here. When you look into the variables wx under the row, we have constant value 0 for variable y. So we will consider w bar in the rows. Let's go for the columns now. when you look into these two values of the columns, we have 0 as a constant value for variable z. Now the product term for this quad is w bar and z bar. W bar and Z bar. Now let us write the product term for the next quad. So when you look into the rows of these two, that is, this quad is occupied by these two rows and these two columns again. So let me check for the rows. When you check the rows, we have a constant value 1 for variable x. So we will consider that constant value for variable x. And in the columns, when we look into these two columns, we find that 0 is constant for variable z. So the product term for this grouping is w z bar. Okay, so it is x z bar. So the product term here is x z bar. Now let us write the expression for this. The expression will be f equal to f of w x y z equal to, it is y bar plus w bar z bar plus x z bar. So this is the simplified SOP expression for the given Minterm canonical form. The next function is f of abcd equal to a bar plus b plus c plus d bar, a bar plus b bar plus c plus d dot a plus b plus c bar plus d bar dot a bar plus b plus c plus d. It is a Maxterm canonical form. For the given Maxterm canonical form, you need to plot the K-map by placing logic zeros in it. So let me write the K-map and plot the given Boolean function. So this is 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Now, better way to plot the K-map is to write the binary representation for the equations here. So let me write the binary values. For every max term, complementary variable will be considered as 1. So this is 1, 0, 0, 1, and this is 1, 1, 0, 0, and this is 0, 0, 1, 1, and this will be 1, 0, 0, 0. For these respective cell numbers, we need to place logic zeros in the K-map. So let me plot the K-map for this. So we have 0 here, 0 here, 0 here, and 0 here. In the remaining cells, we will place logic 1s. See here, this the first max term gives the value 9. The second max term gives the value 12. Third max term gives the value 3, and the fourth max term gives the value 8. With these respective cell numbers, you have to place logic zeros. Okay, so let us now obtain the simplified SOP expression. The simplified SOP expression can be obtained by grouping logic 1 cells. Okay, and in order to obtain simplified POS expression, we need to group logic zeros. Let us now obtain the simplified POS expression, because in the previous slides we have obtained simplified SOP expression. In this example, we will obtain simplified POS expression by grouping logic zeros. So octet is not possible. Quad is not possible because we don't have adjacent 4 logic 0 cells. Pair is possible. So we can form a pair here and we can form one more pair here. One more logic 0 is left out. So you cannot form octet or quad in order to cover this logic 0. We can go for only a single. So let us now write the simplified POS expression. Before we write the simplified POS expression, we shall write the sum term for each of the grouping. Why we are going to write the sum term? Because we have group for logic zeros. So let me start for the first grouping single. Look into the rows and column of this particular cell, that is single grouping. So we can write this as A plus B plus C bar plus D bar. A plus B plus C bar plus D bar. Next, the next pair, we shall consider the rows and columns of the pair here, and we shall write the sum term. We can write this as A bar plus C plus D. And for the next pair, we have a sum term A bar plus B plus C. So these are the sum terms for the grouping whatever we have done. So let's write the simplified expression now. Simplified expression, that is POS expression, will be F equal to A bar plus C plus D dot A bar plus B plus C dot A plus B plus C bar plus D bar. So this is the simplified POS expression.